All right, so today we're looking at this concept of linear growth and decay. And we're going to be using recurrence relations to do that. So linear growth and decay is when your amount is going to increase or decrease by a fixed amount. So that amount doesn't change, it remains the same from one value to the next. And examples of this in finance are simple interest, which is where you earn an extra amount and it's added to your total, and flat rate and unit cost depreciation, which is where your item loses its value according to a fixed cost. So the rule for linear growth and decay, there are two recurrence rules that you need to use. However, the only difference between the two is whether or not you are adding or subtracting the D value based on whether or not you're supposed to be increasing your amount or decreasing your amount. Okay. So there are two steps to setting up these equations. First of all, you need to identify your starting value, which is the amount of money that you're going to start with, and then you're going to need to do a calculation to work out the amount of interest or depreciation that is going to be added or subtracted from your total. So we're going to start off by looking at simple interest. So interest, there's two different kinds of interest, but interest is basically extra money that is added on top of a loan. And it can be good and bad because depending on whether or not you owe the money or the money is already yours, interest can either be in your favor or not. So if you take out a bank loan, the way that banks make their money is that they charge interest on that loan, which means you pay back more than what you actually borrowed in the first place. Simple interest is calculated at a fixed rate. So the amount that you pay back each time, or the amount that it gets charged to you each time, is the same amount. And it's always paid at the end of the loan. So there's not a lot of examples in the real world of simple interest occurring because it doesn't really favor the banks all that much. They don't make very much money on it, basically. But it is often used in things like hire purchase, which with the introduction of afterpay isn't used all that often nowadays either. But anyway, our recurrence relation for simple interest is given by this example here, and the only calculation that you actually need to do is working out our D value. From there, you just need to substitute in this equation, you just need to substitute in the value of your principal and then the value of D. They're the two things that you need to put into this equation to generate your recurrence relation. So let's have a look at this first example. If we invest, so I put $3,500 into the bank. So some of our key terminology here. Invest is an important word. Oops, that's got a highlighter. Alright, because money has direction. It's either going to be positive or negative. And we need to be aware of the direction that the money is flowing in. It's not so important now, but it is going to become more important later. So words like invests, withdraws, deposits, those kind of words are important to look at because it tells you the direction of the money. So if Lano is investing the money, that means that he is putting it into the bank, so money is leaving him. So when you receive money, that makes you happy, so it's going to be a positive value. When money leaves you, that makes you sad, and that's going to be a negative value. That's going to be a bit more important later, but that is a key word that we need to look at here. So we're going to write a recurrence relation for this investment. Now we need to only work out our principal value, which is the amount that you start with, and our value for D. So I'm going to calculate my value for D first. D is going to be equal to my R value, which is 3%, divided by 100, times by V0. And that's the initial amount that we start with. So I'm starting with 3,500. So we're going to work out what that is. So 3 divided by 3,500. That's 105. Perfect. Alright, so then now that I've got my D value, I can write out my recurrence relation. Starting with my V0 amount, which we've already decided is 3,500. And Vn plus 1, that stays the same, equals Vn. So the next amount will equal the current amount plus our value for D, which is 105. And that will be our recurrence relation. Now I'm going to use this model to determine the value after 5 years. So that means that I need to find V5. We're going to use our calculator to generate these terms. You can do it by hand, but it's much easier just to do it on our calculator. So we're going to use our CAS to perform 5 iterations. Right, so again, I'm going to start with $3,500. That's not what that is. 3,500. That's my V0 amount. And then each time I'm going to add 105. So 1 iteration, 2 iterations, 3 iterations, 4 iterations, 5 iterations. Gives us $4,025 after 5 years. Okay, 4,025. When will this investment first exceed 500? But again, for this one, we can again just continue to perform iterations on our calculator until it increases past 5,000. We're going to do it until it's more than 5,000. So we've already done 5 iterations here. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 iterations. So it's going to take 15 years. Alright, moving on to depreciation. We're going to be using the exact same formula, the only difference being that this time our D value is going to subtract. We're going to be reducing the value rather than increasing it, because with depreciation this is where an object or a appliance or whatever loses value over time. So rather than increasing, it's going to decrease. So our steps are going to be exactly the same. We're just going to be subtracting our D value rather than adding it. V0 represents the initial value of our thing, rather than the principal, which is the same as an initial value up here. So up here we're talking about P being the principal. That's the amount that you start with. It's still the same down here in flat rate depreciation. V0 is always the amount of money that you start with. Alright, so we've got, this time in this example, we've already got the recurrence relation, so we're not being asked to work it out. We've been given that information, so we just need to be able to interpret this information. So the initial value, we know that the initial value is given by V0. So therefore the initial value of this computer must be 9,500. And if we want to find its value after 4 years, we're going to again use our CAS, perform 4 iterations. Ooh, spelling. So I'm going to start with 9,500. Very important that you hit enter first, and we're subtracting 950. So minus 950, and we're doing that for 4 years. Yep. So 1, 2, 3, 4. So the value after 4 years is 5,700. Cool. Right, our final type of depreciation is this thing called unit cost depreciation. So this is where rather than decreasing by a certain fixed amount each year, devices decrease based on the amount of use that they have had instead. So a car might depreciate by the amount of kilometers that it has traveled. What else could there be? Oh, well, we've got this photocopier. So a photocopier could decrease based on how many pages it's photocopied. So in this equation, the D, rather than representing the fixed amount of depreciation, is going to represent the cost per amount. So if you look at this example, the photocopier is purchased for 1,200 and depreciates at a rate of 8 cents for every page. If we were to write a recurrence relation for this, we only need to put in our initial value, the starting value, and then how much it's depreciating per page. Now we need to be a bit careful here because our cost has been given in dollars, but our depreciation has been given in cents. So we need to make sure that that's in the same units. So V0 is our initial cost, which is $1,200. Vn plus 1 equal Vn minus, I need to convert this into dollars. So this will be 0.08. You have to be careful and make sure that we have the same units for that one there. Alright, now if we need to find the value of the copier after 20 pages have been copied, well, you can do 20 iterations on your calculator if you like, or what we can kind of cheat in this one, and you could multiply 0.08 by 20 and then just subtract that amount. So we could do total depreciation calculation is going to equal 20 pages times by 0.08. So, .60. And then we can do 1,200 minus $1.60, which is 1,198.40. Yes. Rather than going on to our CAS and doing 20 iterations. I mean, you can do that, but it's kind of annoying to keep track of. But yeah, not many people want to do that. Alright, so you guys have got a couple of exam questions there to have a go at. I will put the solutions to them up on our class notes a little bit later so you can double check. But that is using recurrence relations to model linear growth and decay. So remember, the key thing here for linear growth and decay is that things are always going to be either increasing or decreasing by a fixed amount. And our key terms to look out for in this case: simple interest, flat rate depreciation, unit cost depreciation. Now, questions are always going to tell you, they'll mention, you'll have in there simple interest, flat rate, or unit cost. That will be the key phrase in your questions as to which one of those you are looking at.